The functioning of quantum particles, interpreted as lit pixels on a screen structure, may be the solution to the strangeness of the double-slit experiment. The famous wave behavior, which suggests that a particle can be everywhere at once while unobserved, may indicate a rendering mechanism projecting the universe. By drawing parallels with digital processing technology, we understand why the system does not process the three-dimensional image of a photon that is not being watched. Quantum superposition operates as a data economy. If there is no interaction with that specific point in spacetime, the data is simply not rendered on the universal screen. Just as digital pixels can light up at any position across the entire extent of the screen, elementary particles can emerge as excitations of fields that expand throughout spacetime. This concept explains why the particle appears omnipresent and without a defined position as long as we do not interact with it. The event of quantum excitation can occur anywhere in space, and this explains its probabilistic and superimposed nature. Just as pixels do not physically move to create motion, but rather light up in a coordinated animation sequence, elementary particles do not travel a continuous trajectory like a sphere through space. They are excitations whose probability of existence changes in space and time, shaping what we perceive as movement. It is as if the lack of interaction with the moment of passage does not require organizational coherence of field excitation or lit pixel, such as following a straight path or passing through one of the slits, leaving open the infinite probabilities of where the particle might be lit. Just like on a digital screen, electrical signals are not triggered in any pixel when there is no image being rendered because nothing was calculated or processed by the system. In space, the particle has no defined position because the moment of passage was not processed. It did not render as a defined solid image, but rather a probabilistic one. Here, the resemblance of quantum behavior to the digital pixel rendering mechanism is undeniable. The system behind our reality resembles a quantum supercomputer that calculates infinite probabilities simultaneously, collapsing into a coherent result only when there is an interaction, whether by a measuring device or an observer, forcing the information to take shape within the classical structure. This study was developed and registered in the CERN Scientific Repository, reaching more than 60 accesses from the academic community in less than 2 months. And I, Sarah Athaid, invite you to embark on a journey of reinterpretation and unification of quantum and classical physics through the concept of spacetime rendered as an emergent interface of a screen structure. This is the dynamic of software and hardware that can finally reconcile all the loose ends, strangenesses, and paradoxes that traditional science has been unable to reconcile until today. Access the scientific research published as the book Four-Dimensional Interface, Spacetime, and discover how the answers have always been right under our noses. Link in bio.